Hello friends, today we are guiding you to prepare interview questions on Python. In comments you can share the topic of your interest. Our team will prepare the video for you. Before continue to our session, we request you to join our channel for all the latest updates. Our team of technical and subject matter experts are working hard to create valuable content just for you. So please make sure to hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. What is the difference between SQLite and PostgreSQL? SQLite and PostgreSQL are both popular relational database management systems, but they differ in several key aspects. Architecture: SQLite is a lightweight, serverless, embedded database. It stores data in a single file on disk and doesn't require a server to operate. It's best suited for local applications or small-scale use cases. PostgreSQL, on the other hand, is a client-server database system. It operates with a dedicated database server, which makes it more suitable for large-scale applications, enterprise systems, and multi-user environments. Scalability: SQLite is designed for smaller, single-user applications and can handle moderate-sized databases. It's not as scalable as PostgreSQL and can struggle with heavy concurrent writes. PostgreSQL is highly scalable and can efficiently handle large databases with many concurrent users and high transaction loads. It supports advanced indexing, replication, and clustering for scalability. Features: SQLite supports a basic set of SQL features, ideal for simpler tasks and embedded systems. PostgreSQL is feature-rich, supporting complex queries, transactions, ACID compliance, foreign keys, and custom functions, among others. It's also extensible with support for plugins. Use cases: SQLite is great for mobile apps, small-scale websites, and desktop applications. PostgreSQL is suitable for large-scale web applications, enterprise solutions, and data warehousing. What is NORM, and how does Scalchemy work? NORM, Object Relational Mapping, is a programming technique that allows developers to interact with relational databases using object-oriented programming languages. It acts as a bridge between the relational database and object-oriented code, enabling developers to work with database tables as if they were regular Python classes and objects, eliminating the need for manual SQL queries. With NORM, developers can define database schema and relationships directly in code. Operations like create, read, update, and delete (CRUD) can be performed using Python objects instead of writing raw SQL. This abstraction makes database interaction more intuitive, improves maintainability, and reduces the likelihood of SQL injection vulnerabilities. Scalchemy is one of the most popular Python libraries that implement ORM functionality. It provides a high-level API to interact with relational databases like SQLite, PostgreSQL, MySQL, etc. In Scalchemy, you define classes that map to database tables, and these classes can be used to perform queries, insert data, update records, and delete data. Scalchemy uses a two-layer architecture: the core, which works with SQL expressions, and the ORM, which uses Python classes. Scalchemy helps streamline database operations by handling SQL queries internally while still allowing complex querying capabilities when needed. How do you perform CRUD operations using Python? Performing CRUD, create, read, update, delete operations in Python typically involves interacting with a database using libraries like Scalchemy for ORM, Object Relational Mapping, or SQLite 3 for direct SQL queries. Here's a brief guide on how to perform these operations. Create: to insert data into the database. You can use the Insert into SQL query or utilize ORM models in libraries like Scalchemy. Here's an example with Scalchemy: new_record equals my model name equals John, age equals 30 session.add new_record session.commit. Read: to fetch data, you use SQL queries or ORM queries like filter and all in Scalchemy. Result equals session.query my model. Filter my model.age greater than 25. All print result. Update for updating records. SQL queries use update, and with SQL record equals session.queryMyModel. Filter myModel.id equals 1. First record.name equals Jane session.commit delete to delete records. Use delete in SQL or delete via ORM. Record _to _ delete equals session.queryMyModel. Filter myModel.id equals 1. First session.delete record _to _ delete session.commit. In these examples, session.commit is used to save changes to the database after each operation. What is the difference between MishClB and SQLite 3 in Python? In Python, both MishClB and SQLite 3 are libraries used to interact with databases, but they differ in the type of databases they connect to, their functionality, and use cases. Database type MishClB. This is a connector for MySQL databases, which is a powerful, multi-user relational database system commonly used for large-scale applications and websites. It requires a MySQL server to run, either locally or remotely. SQLite 3. This library is used for SQLite, a serverless, self-contained SQL database engine. SQLite is a lightweight, file-based database, ideal for small to medium-sized applications or for development and testing purposes. Installation MishClB needs to be installed separately, for example, using pip install MishClB client, and requires a running MySQL server, along with proper configuration. SQLite 3. It comes pre-installed with Python, since Python 2.5, making it easier to use without additional setup. Use cases MishClB, suitable for larger, more complex applications that need to manage a substantial amount of data with multiple users and remote access. SQLite 3, best suited for smaller applications, local databases, or when a serverless, file-based database is needed for simplicity and speed. Finally, MishClB is for large-scale, multi-user databases, while SQLite 3 is for simpler, file-based storage systems. What is unit testing, and why is it important? Unit testing is a software testing technique where individual units or components of a software application are tested in isolation to ensure they work as expected. A unit typically refers to a small, specific part of the code, such as a function or method. Unit testing involves creating test cases for each unit of the code, running them, and checking the results. The key purpose of unit testing is to validate that each part of the code base performs correctly. It helps identify bugs early in the development process, making them easier and cheaper to fix. Unit tests are often automated, meaning they are executed automatically as part of the development process or continuous integration pipeline, providing quick feedback to developers. Unit testing involves creating test cases for each unit of the code, running them, and checking the results. Unit testing is important because early bug detection, catching issues at the unit level ensures that they don't propagate into larger, more complex problems later. Code quality. Writing unit tests encourages developers to write cleaner, modular code. Refactoring confidence. Unit tests allow developers to confidently modify or refactor code, knowing that any breaking changes will be immediately detected. Documentation. Unit tests act as documentation, showing how each unit is expected to behave. In summary, unit testing improves code reliability, maintains code quality, and provides a safety net for future changes. How does Python's memory management differ from languages like Java or C++? Python's memory management differs from languages like Java and C++ primarily in terms of automatic garbage collection, dynamic typing, and memory allocation strategies. Garbage collection. Python uses automatic garbage collection through reference counting and a cyclic garbage collector, via the GC module. Garbage collection in Python. Python uses automatic garbage collection through reference counting and a cyclic garbage collector, via the GC module. When an object's reference count drops to 0, it is immediately eligible for memory deallocation. However, cyclic references, where objects reference each other in a cycle, are handled separately by the garbage collector, which runs periodically to clean up such cycles. Garbage collection in Java. Java also uses garbage collection, but it is managed by the JVM, and Java does not rely on reference counting. Java uses generational garbage collection, which divides objects into young and old generations for more efficient memory management. Garbage collection in C++. C++ has manual memory management, meaning that the programmer must explicitly allocate and reallocate memory using new and delete, or malloc and free. This gives more control but increases the risk of memory leaks and dangling pointers if not handled properly. Memory allocation. Python uses a private heap for object storage, where all Python objects are allocated from this heap. It also optimizes memory usage by employing small object pools. While Java also uses a heap for memory management but divides it into regions like the young, old, and permanent generations. But C++ allows direct control over memory allocation and deallocation, providing more flexibility but also higher responsibility. Overall, Python's memory management is more automatic and abstracted compared to Java and C++, which offer more control but require careful management. Thanks for watching the video till the end. If you liked the video and haven't subscribed yet, please hit subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. In comments you can share the topic of your interest. Our team will prepare the video for you.